Hello, this video is going to show you how to make a change and contribute a change to the Dart SDK, more specifically to the co-libraries. On an example of a very concrete change, adding methods to the RegExp class to access start and end positions of capture groups. So there is an issue that has been filed around 4 years ago, 5 years, asking the RegExp API to be extended with this information. And this issue has not been addressed, so I'm going to use it as an example of contributing a change to the Dart SDK. So it's a step-by-step guide. So step 0 is to ask the team. Asking the team before you actually jump into implementation will save you a lot of time, because the team might have tried to make the change and failed for some reason. The team might have considered the possible design, at least they will be able to suggest you design once you ask. And finally, the change you're trying to make might not be aligned with the priorities of the Dart. So it will be rejected and you will not be able to contribute it upstream anyway. So before you jump into implementation, it's better to always ask. Okay, here we have already an issue that is filed, and on the issue we can see that there is some consensus that this should be implemented, and we just didn't get to implementing it. So it's safe to proceed. The first step is, of course, to get the source code and read documentation on how to contribute to Dart SDK. So in the Dart SDK root, there is contributing.md, which you should read to figure out all the details. And it links to another markdown file called building, which contains instructions on how to check out SDK sources and what kind of build dependencies you need to install. The Dart SDK is not a simple Git repo that you can clone. It has a bunch of other dependencies that are pulled from other places. And this is managed by a tool called gclient, which is part of Depot Tools. There is a link to Depot Tools here. So you'd first need to install Depot Tools, and then using Depot Tools, you can get a checkout of a Dart repository, of a Dart SDK repository. So once you have done all of that, so you make some folder for Dart, you fetch Dart into it. Fetch is a tool that comes from Depot Tools. You get a normal Git repo with a bunch of other stuff inside. So here I have a repo. To update it, to keep it updated, I do just like what any other Git repo does, but also I need to pull additional dependencies using the gclient tool. So here I updated the repo, I pull additional dependencies. Okay, perfect. So we have an up-to-date source. To build the source, I use two helper scripts. There is a build.py script, which allows me to build things. So for example, if I want to build a release build of Dart binary, I type tools build.py -m release Dart. And this will build a release binary, the Dart binary, which can be used to run Dart code. So we are waiting for the build to complete. Okay, it's done. So let's try to test it, just to show you that it's actually a working binary. So it locates on the Mac, it is located in the Xcode build release ARM64, and then I can say Dart hello.dart. Okay, it runs. So we have now a working version of Dart. Great. So next step. So we got the source, we can build it. We are making a feature in Dart. When you're making some sort of a feature, it's a good idea always to start writing a test. So here's an example of such test. which creates a regexp, makes a match, and then checks that our newly created API with captures and like named captures, it can access the information about capture group positions within a string. The tests in the SDK checkout are located in the test subdirectory, and in that subdirectory there is other subdirectories for more specific parts of the SDK. For example, tests core lib includes the test for the core library. So we can place our test into the tests core lib regexp capture test. So we create a file there. I already actually created a file. So with the test contents. So we can run this test now by using another helper script. For example, tools test.py mode release, and we pass the name of a test. And of course, test fails because we did not yet add any changes to the SDK itself, so none of these methods that the test is using exist, and the test fails. So here it says failed. Okay, 0 test passed, 1 failed. Fantastic. Okay, great. We have a test, we can run it, and it fails. So that was the step 3. Oh, I notice now that the steps are numbered incorrectly, so this should be 2, 3, 4. Okay, anyway. Yeps. So we wrote the test. Now we make changes. So when you make changes, you need to find which files to change. If you work with SDK for the first time, the best way is to just search for the names of the classes that you think you need to change. Like for example, here we are planning to change the class called RegExpMatch. We are planning to extend its API with some additional methods. So what we do is we just take and we grab the SDK sources for the places where this class is defined. So we grab, well, lucky we are, there is a single place where it is defined. We can look at this file. And indeed, that is a definition of a RegExMatch class. You can notice that this is just the interface of the class. It doesn't actually contain any implementation. That's because many parts of the SDK are implemented in a platform-specific way. For example, here we have a regexp, and on the native, on the VM implementation, we use our own regexp engine, and on the web we use regexp that is built into the JavaScript engine. So that these two implementations are different. In the SDK sources, these implementations will be located in different parts of the SDK. So we need then to search for classes that implement this class to provide the platform-specific implementation. So we search and we find 4 different implementations. So there is a VM implementation, which we are going to change first. There is a WASM implementation. There is a Dart2JS implementation and a DDC implementation, which is a JavaScript development compiler, which is the one that you use when you want to quickly compile Dart code to JavaScript during the development time. Okay, so we kind of located what we need to change. Now let's apply the changes. So yes, first we start by changing the platform independent interface. We take this patch, and this video is focused on actually showing you how to make the change and then send this change for review. I'm not focusing too much on the coding itself, so I'm going to type this line by line. I'm just going to apply this patch. And the patch is very simple. It just adds 2 methods to the interface, no bodies, just the signatures. So we added the platform independent interface. Now we need to change the implementation. The implementation for the VM, as I have shown before, it's located in this SDK lib internal VM lib RegExpMatch. We update it to include the implementations of the methods that we have just added to the platform independent interface. Okay, so we updated it. Let's just look at it a little bit. So these are the methods that we added. There are two methods, one to get the captures and one to get named captures. The way that you usually approach it, so like imagine you don't know what to write here. So what to write, you don't know. You need to look at the surrounding code. You start reading this class from the beginning and you immediately notice, well, apparently there is a method to access the start position of a group knowing the group index. There is a method to access end position of the group knowing the group index. Well, that's exactly the information that you need here. And then there is a method to access a number of groups. And that's it. That's all you need to know. So you just make a list and then you fill it up with information that is returned by these already existing methods. And similarly with the named captures, you look around. Okay, there is a group names method. There is a named group method which returns a group by a name. You can see how they implement it, and using that information implement the named captures method. Okay, so we have figured how to do it. We have done the implementation. We need to rebuild our Dart binary. The binary is building. Okay, and now we run our test. And it should pass. No, it fails. Well, I intentionally included a typo into the patch just to show you how the experience is. So for example, here it says, well, type string is not subtype of type int in the typecast, and it's in the method that we have added. So it did call our newly added methods. It's no longer complaining about the syntactic error that there is no such method defined in the RegExpMatch class. It actually calls it. But something is wrong in the implementation. So you look at what is wrong in the implementation, like you can go to this line. Oh, I noticed that there is a +1 missing here because I omitted it. Now we build it again. Okay, you test it again. And the test passes. We are ready to ship. Well, not really, because we have modified just one of 4 different platforms that Go libraries support. We have modified the native VM implementation, but we still have Wasm, Dart2JS, and the DDC to modify. We repeat the same process. So we say, okay, we have fixed the VM implementation, we have fixed the platform independent interface, we go Dart2JS. We again take the patch. I'm not going to walk you through the patch. There is a difference though, is that now we're using the built-in JavaScript regex implementation. So we're using JavaScript to access the information. There is a bunch of JS interop involved. So we patch the JavaScript runtime implementation. Then we rebuild again. We built now a file that is needed for Dart2JS to compile and run things. And then we run the test on Dart2JS. And here you see it says the same command line tools test.py, but now we say, please use Dart2JS compiler to run this test. And the test is running. And it passed. Okay, fantastic. Here, if you look at the patch, you would notice that when constructing a regexp, I now always pass the d modifier to the regexp constructor, because in JavaScript, the information about start and end positions of capture groups is only exposed to the caller if you construct regex with d modifier. So, and in the API design, in the platform independent interface in Dart, we made this information always accessible. We don't pass any additional configuration to the regex constructor. So the way I had to implement it is that I always pass this D to the regex constructor on the JavaScript side. The question that will arise here once you send this to a reviewer is the reviewer will most likely ask you a question. Well, what's the cost of always passing this D modifier? Is it slower? Is it faster? In a preparation, it's better to benchmark. So you could write a small benchmark in JavaScript and run it just to try to assess what is the cost of that is. And the cost is non-negligible. There is, like you see here, without a modifier, a regex on a short string takes 30 nanoseconds to match. And once we add the modifier, it adds another 40 nanoseconds on top to construct this array of indices, which describe start and end positions of the capture groups. And you can vary this benchmark a little bit, get more information about the cost. It seems to be linear to the number of groups. It seems to be the baseline cost is around 40 nanoseconds on my fairly fast laptop. You should add this information when you send a code review so that the code reviewer can look at it and maybe make suggestions. Maybe we actually have to pass this as a flag to the regex constructor instead of always enabling it. Even though on the Dart side, you always can access these indices without any additional cost, because as we have seen when we were adding this code patch to the native implementation, the information is already there, it's available. Okay, so we did the JavaScript change, we benchmarked things a little bit. We now change the DDC implementation in the same way as we did with Dart2JS implementation. We built necessary files again, the same pattern. We changed the core libraries, we rebuilt some artifacts that are needed to run the tests. And then we run the test and we specify that now we are testing on the DDC compiler. Previously we were testing on the Dart2JS compiler. Okay, we run the tests. Spawned a browser there. Test has passed. Fantastic. So we have done VM, Dart2JS, DDC. Now we change the WASM in the same way. And we do the same thing where we built Dart2WASM files now. And then we test once the build completes. It's now building, like, it compiles the core libraries to some binary format, it compiles necessary tooling, Dart2WASM compiler itself, and just takes time. Takes less time when you are rebuilding after doing a smaller change. Okay. We're running the test and it passed. Okay, so we have now implemented it on all platforms. Fantastic. We have a test, we have made changes. Now we are ready to make a CL, which is send it for code review. So for code review on the Dart project, for SDK, we use Gerrit, which is a code review tool. and we do take smaller changes through the GitHub PRs, which are automatically synced into Gerrit, but the actual review happens on Gerrit. So it's better to learn how to use Gerrit. You need to log in into Gerrit. You need to put some stuff into your Git cookies. There is links in the contribution guidelines and here how to do it. Once you're all set up, you just follow kind of a Git workflow, like you make a branch for your changes. I use this helpful new branch command, but I can also create branch using normal Git commands. And I say, for example, okay, I create this change. I add all the changes to it. So I add all the files, I update all the files. Right, I think that's it. I commit and say this is a change in core leaps. Expose capture group positions in match. Okay, so I have now a branch and I have a commit on the branch. What I do then to create a code review for this change is I type git cl upload, and that would run some pre-submit checks on the branch, on the squashed history. So if you make more commits to this branch, all of them will be squashed into one. And for example, here I did not format everything correctly, so I need to reformat. It gives me some commands how to do that. So I reformat. I can check, okay, some stuff has moved around. I can commit more to the branch, but as I have said, when you create a CL, it does not matter what individual commits are. They're going to be squashed. I try again. Okay. So now it asks me to create a description for the change, and it would be nice to follow guidelines that we have on a wiki for these descriptions. We have this commit message best practices, but I think for starters I can just say that this exposes capture group positions in RegExMatch. I think that is good enough. It's a change in the core leap. Okay, I save this description, it uploads, and it creates a new code review. Okay, so it gave me a link. I can navigate to this link. So this is Gerrit. You see all the files that I have changed are here. The change right now is not sent for review, it's just uploaded. And unless you send it for somebody to review, it's just going to sit here and nothing will happen. So you can go through these changes, through these files, check wine final time, maybe leave some comments. For example, you can go to the JavaScript runtime here and say, well, I have benchmarked this and found out that capture group. Okay, so that's the cost. So something like this. maybe we should consider adding a flag to RegExp constructor to enable this functionality instead of unconditionally Okay, so this comment, as you can see, it says a draft, so it is not yet sent. You see, this draft is only visible to you. To publish drafts, click reply or start review button at the top of the change, or press the AK. Okay, so I press reply here. I add the reviewer. Co-library changes have to be reviewed by Lasse, so I add Lasse here. If you don't know whom to send the change to, you can also just take the link to the Gerrit code review and post it on the issue tracker in the issue where you discuss the implementation of a particular feature, and then the team will take care of triaging it. Okay, and then I just press send. And this goes to Lasse. Okay. One thing that I noticed here after I send it is that my test is very primitive. It just checks one regexp, doesn't check a lot of functionality. So what if I want to add a little bit more? So for example, I have some slightly bigger test which tests different options. Okay, so I can copy and paste it into my tests. Okay, I save it. So now if I look at the status, the file is modified, I add it, I create a new commit, add a beta test, and I just do git cl upload -f again. And then it will just upload a patch on top of my original change. Again, it will squash all the commits, so the commit descriptions I'm putting into my branch don't matter too much. So let's look at it again. So here it created a patch set 2, I had the beta test, so it uses the commit description here, but otherwise it doesn't really matter. When the change lands, it will be this description that will go into the commit description when it lands. So, and the test is now updated. Okay, and now we have to just wait for Lasse to review this and come back to me with comments. As a Dart team member, I can also start a dry run of the tests, of all the tests, using the CI infrastructure. Externals cannot click this button, so you have to ask somebody on the team to do the dry run for you. So I'm gonna click this and wait for things to happen. Okay, this was the part 1. We will see what happens when Lasse reviews the change.